Welcome to Everything Matters, Tales from the Periodic Table. I'm your host, Ron Hipschman, and tonight we're going to be doing, as you can see, the element silver. So we hope that you enjoy this. So let's get right back to my presentation here. Here is a beautiful periodic table that was produced by Theodore Gray. Incidentally, Theo has written one of my favorite books called, obviously, The Elements. And you can pick it up actually from the online Exploratorium store if you want. Check out his fantastic website, periodictable.com. Silver is the 47th element in the periodic table. Its atomic number is 47 because that's how many protons are in its nucleus. More about that a little bit later. We have no idea who discovered silver. It was one of those elements that was discovered prehistorically. There are about 9 elements discovered before written records. And here you can see which ones. Sulfur, iron, copper, silver, tin, antimony, gold, mercury, and lead. These elements were discovered so early because they all occur in nature in their native state. Speaking of which, here you see a sample of native silver in calcite, and this is a beautiful sample because these are actually crystals of silver. 37 elements actually occur natively. There are good reasons why only 9 of them were discovered very early. Some are so rare that only a small quantity occurs, so they remained hidden. Others occur natively but mixed in with other elements, making their individual identification difficult, especially before chemistry, or chemists for that matter, or even alchemists. Argentite, found in Mexico and the Comstock Lode in Nevada, is a mineral commercially exploited for silver. Argentite is silver sulfide. Another silver-bearing mineral is chlorargyrite, which is silver chloride. The name of this mineral is from the Greek chloros, for pale green, and Latin for silver, argentum, which might give you a clue as to where we get the chemical symbol. This ore is interesting because of the greenish color. It can actually change to brown or even purple on exposure to light. Some silver compounds are light sensitive, and we'll explore that in a bit as well. The Latin, argentum, meaning shiny or white, gives us the chemical symbol Ag. And we get our word silver from a few possible and related sources, Old English zilver, or from the Dutch zilber, or German silber, giving us silver. Silver belongs to a large group of elements in the middle of the periodic table that are called the transition metals. These elements are defined as ones with an incomplete d shell of electrons. This is also known as the d block of the periodic table. The universe produces silver mostly in merging neutron stars. A little bit is also produced in dying low and medium mass stars, as you can see here. Here on Earth, Mexico and South America produce 62% of the world's silver, with the rest spread around the globe, as you can see here. While silver is rare and has made it into the American Chemical Society's endangered element list, it's not as bad as other critical elements, some far more common than silver like copper or tin. How rare is silver? Well, let's see. It's the 69th most abundant element in the universe. It's the 67th most abundant element in the sun, as you can see, pretty rare down there. It's the 62nd most abundant element in meteorites. It's the 67th most abundant element in the Earth's crust, about much less than 1/1,000,000%. And in the oceans, it's actually the 40th most abundant element, probably because most of the silver has dissolved in the waters of the ocean. And in humans, it simply isn't present. There is no silver naturally occurring in the human body. Well, what about its atom? Let's compare the size of the silver atom to that of hydrogen. And we'd see something like this. As you can see, the silver atom is about 3 times the size of a hydrogen atom. Actually, most of the transition elements there in the middle of the table have similar sized atoms to silver, plus or minus a little bit. We can make a little graph of all of the sizes of the atoms, from the largest atom on the left, cesium, to the smallest atom on the right, helium, and silver is sort of right in the middle there. Now, each element has many different forms. For each specific element, the number of protons in the nucleus is the same, and that would be 47 protons for silver. But there can be different numbers of neutrons. All these different forms are called isotopes, and they're chemically identical. All chemistry occurs in the electrons surrounding the nucleus. The nuclei here all have slightly different weights, but chemically, again, they're identical. The number you see next to the chemical symbol Ag is the total number of protons and neutrons in the nucleus. And there are 38 distinct isotopes of silver. And of these, there are only 2 stable non-radioactive isotopes, silver 107 and silver 109. Each of these 2 isotopes make up about half of the silver in the universe. And by the way, the word isotope comes from the Greek isos, meaning same, and topos, meaning place, since they all occupy the same place in the periodic table. Now, if we will look at the longer lasting of the radioactive isotopes of silver, here you can see all of the ones that last over 1 hour. These have half-lives all over 1 hour. What's a half-life? A half-life is how long it takes for half of the isotope you have to decay. So if you wait this amount of time, half of it will be left. If you wait another half-life, half of the half that you have will also decay, leaving you with 1/4, and so on. As you can see here, the longest half-life, 418 years for silver 108, is relatively short compared to the age of the Earth, which is about 4.5 billion years. So there is no radioactive silver around anymore. It has to be made. Speaking of which, here is a souvenir from the American Museum of Atomic Energy. At that museum, you were able to make radioactive silver. You'd place this sample of silver, which in this case is a mercury dime, near a strong source of neutrons, and the silver would become mildly radioactive. Now remember that half of all natural silver is silver 107, and the other half is silver 109. Silver 107, when you add a neutron, becomes silver 108. That has a half-life of 2.37 minutes. The other isotope, silver 109, when you add a neutron, becomes silver 110. And that isotope has a half-life of 24.6 seconds. Both of them pretty short. So if you took your radioactive dime and put it underneath a Geiger counter, you could then easily watch the exponential decay of the 2 silver isotopes created by neutron activation. With such short half-lives, your mildly radioactive silver souvenir was safe to take home after your visit to the museum. Frank Oppenheimer, our founding director, wanted to do this experiment for visitors at the Exploratorium, but we couldn't figure out how to do it safely in the way that Frank wanted to do the experiment, so it never happened at the museum. Neutron activation, as this is called, is an important scientific tool to analyze the chemical content of samples that can be made radioactive. Silver has a density of around 10.5 grams per cubic centimeter. That's how much it weighs in a given volume, the density. We all remember the density of water, that's 1 gram per cubic centimeter, and I've also placed a few other items here and labeled them with their density. You can see here that the density of silver is greater than that of iron by quite a bit, and a little bit less than lead. Let's make another chart with the densest element over on the left and the least densest over on the right. And as you can see here, we normally have blocks that you can lift and feel the density of various elements. Unfortunately, in a webcast like this, we don't have it, but when we start to do this back at the museum, we'll have those blocks available for you to play with. Our blocks have a wide range of densities, with the heaviest at tungsten, and then we have lead and copper and iron and titanium and aluminum And our lightest block is magnesium, that's an element, and here is where silver falls. Silver has a density, again, of about 10.5 grams per cubic centimeter, just below that of lead at 11.34 grams per cubic centimeter. Lead is a little denser. Now, silver is about the 24th densest element. Silver has the 49th highest melting point. It's actually pretty low. Silver melts at 962 degrees Celsius, so you can melt it easily with a torch. And it has a fairly high boiling point, although lower than a lot of other elements. Its boiling point is 2,162 degrees Celsius, so a little harder to boil silver. Silver expands more than a lot of elements. It expands 1 part in 189,000 for every degree Celsius in temperature rise. Now, you notice in this chart that mercury is the champion here. It's the one that expands the most with temperature, and it's a liquid, which is why it's very useful in thermometers. And the one that expands the least on the other end there is good old silicon. As far as hardness, silver is relatively soft. It has a hardness of only 2.5 on Mohs scale of hardness. It's about the same hardness as pure gold or zinc. It's also, because it's not very hard, it's also very malleable. You can hammer on it and it'll change shape, and that's going to become very useful when we talk about jewelry later on. Here's a graph from hardest to softest. Again, the hardest on the left with boron and the softest on the right with cesium. Cesium is so soft you can cut it with a butter knife. And silver is right around the middle. As far as being exceptional, electrical conductivity is where silver is tops. Silver has the highest electrical conductivity of all the elements, even better than copper. We don't normally use it for wires, though, because of its cost, and we'll get to that in a moment as well. Silver also has the highest thermal conductivity of all the elements, and we'll see where that becomes useful in a bit as well. Now, if we look at the silver spectrum, here we brought out our periodic table of the spectra. Silver has a spectrum that has very few red colors, but a good bright green and a few bright blues. So if you could vaporize silver and excite it, it would probably look greenish blue or kind of a turquoisey color in a flame. Now, I said we're going to talk about the cost of silver. Let's do that. Silver isn't the cheapest element, but it's not the most expensive either. On the date this program was made, silver was selling for $17.35 per troy ounce. We'll do a little bit more on what troy measurement is in a bit. You probably won't be buying silver in a huge ingot like you see here, which weighs about 1,000 troy ounces, which is over 68.5 pounds. The price of silver changes, sometimes rapidly, and that really depends on supply, demand, economic and political conditions, and other things. You can see here the last year's price fluctuations, and specifically you can see that silver took a pretty sharp dip in the late March and early April because of the current medical situation that we're in right here. But it's back up to about little over $17 now. Normally, when you purchase silver, you buy it in somewhat smaller bullions. Here is a 10 troy ounce silver bullion. I've actually invested in silver in the past. And when I invested in silver, I invested in 1 ounce bullions. Here's a 1 ounce bullion right here, and you can see how it's pretty thin. And that is the way that most people would invest in silver, is with smaller bullion. You just have to deal with more of them. Now, I said we would talk a little bit about troy weight. Troy weight is, again, one of the British system measurements that we've been left with. Precious metals are always measured in troy ounces. So gold, silver, platinum, palladium, all measured in troy ounces. Troy weight is a system of units that originated in 15th century England, so it's an old system of measurement. It was based on grains. A grain is the mass of a single virtual ideal seed of a cereal. Today, we've defined that to be exactly equal to 64.79891 milligrams. There are 480 grains, or about 31 grams, in 1 troy ounce. And in the troy system, there are 12 troy ounces in 1 troy pound, or about 373 grams in 1 troy pound. Now, the measurement system that we use, normally when we consider weight, ounces and pounds, we use a system that is pronounced either avoirdupois, if you're pronouncing it in the French version, or if you're an American, you might pronounce it avoirdupois, weight. This is what we normally use as a system of weight measurement in the United States, since we have yet, unfortunately, to convert to the metric system. Here, there are about 437 grains, or about 28.3 grams per ounce, and we have 16 ounces per pound. This means that if you weighed a pound of anything in our system of measurement, say feathers, measured in avoirdupois, those feathers would weigh more than a pound, measured in troy measurements, of silver or gold. Because you can see a pound in avoirdupois is 453 grams, and a pound in troy is 373 grams. So a pound of feathers is about 21% heavier than a pound of gold. An interesting fact. Silver, given its scarcity, has been used as monetary exchange. The value of the metal represented the value of something you wanted to acquire, like food or tools or labor. The coin on the left dates very early, from 261 BCE. In the middle is a 10 rupee bar. That weighs, I weighed that, it weighs about 150 grams. It's worth far more, around $75 today, than the face value of it when it was minted, which was at that point maybe $10. I can show you that too. Here is the 10 rupee bar, and you can see it's it's a little bit thicker than that 1 troy ounce bar that I showed you. It's about 3 troy ounces there. So let's go back to the slides. And on the right-hand side there, we see a commemorative coin minted in Poland that was minted to celebrate the elements radium. You can see that impressed on it, the elements radium, Ra, and polonium, Po, which was obviously named after the country. And it also celebrates the discoverers who you see on the coin as well, Marie and Pierre Curie. Marie Curie was a celebrated Polish scientist. Other than the penny and the nickel, U.S. coins from 1964 and before contained 90% silver. During World War II, the element nickel, not the coin, the element nickel became a critical resource, and nickel coins at that point were 75% copper and 25% nickel. They needed the nickel in the war effort. So from mid-1942 to 1945, wartime nickels were 56% copper and 35% silver, and a little bit more of other metals like manganese. You can tell wartime nickels because their mint mark, which mint they were made at, on the back of the coin is above the image of Monticello. Here you see a P there. That means it was minted at the Philadelphia Mint. Normally, that P would have been found on the front of the coin for all other non-wartime nickels. Current dimes, nickels, quarters, and 50-cent pieces have no silver. They're 8.33% nickel and the rest copper. And I've noticed that they don't jingle very nicely compared to silver coins. Let's try that. I have a little demo. So I have some coins here, and these are the current copper-clad nickel and copper coins. Let's listen to those. I'm going to jingle them in my hand here. I think they kind of thud. They don't jingle very well compared to the silver coins. Here's the equivalent silver coins I'm going to jingle now. See how nicely those jingle? Sorry, I just don't like the new coins compared to the old coins. The silver coins are much, much nicer. Speaking of coins, I got the thought. What are silver coins worth today? Silver coins, as I mentioned, except for the wartime nickel with its 35% silver, all of them contained 90% silver. So let's make a little spreadsheet here and figure out what the value of the silver is in the coins. What I did was I weighed each coin. Yes, I'm kind of a geek that way. And here's the weight of each one of those coins, including the 35% silver nickel. And that's the mass in grams. And I looked up the price of silver, which we've already talked about. At this point, it's $17.35 per troy ounce. And from here, it's actually pretty simple. You can now see that the value of each coin is, wow, quite a bit higher than the face value. So the nickel is worth 96 cents. The dime is worth $1.23, the quarter $3.14, the 50-cent piece is worth $6.23, and the dollar, a silver dollar, is worth $13.55. This is what you would call the melt value, only the value of the coin for its silver, not including any mint cost of actually making the coin. So this is why we don't make coins out of silver, and why I don't get my jingly coins anymore, is the cost of the silver in these coins is far more than the face value of the coin itself. As a matter of fact, if we want to know the multiplier here, here's the face value multiplier. The nickel is actually worth 19 times its face value, and the others are worth around 12 times their face value. Our paper money used to be a stand-in that represented actual silver and gold that the government had on deposit in various storage vaults like Fort Knox. The paper was just easier to carry around than the metal. This is a silver certificate. They were issued between 1878 and 1964. Note, if I circle it here, that it promises you can turn it in for the real deal. It says there, this certifies that there is on deposit in the Treasury of the United States of America $1 in silver payable to the bearer on demand. Nowadays, our paper money is just that, paper. There's no precious metal behind it. This is the Fort Knox of silver, and it's the West Point Mint in New York. Originally, it was called the West Point Bullion Depository. Now, there was that silver coin that was made out of, the silver commemorative coin that was minted in Poland. I have one in my collection here. This is a silver commemorative medal minted in 1969 to celebrate California's bicentennial. And it weighs 5 troy ounces. And it's not 90% silver, it's 100% silver. Silver's been used for statuary as well. Here we see an ancient silver Egyptian figurine of Horus as the falcon god with an Egyptian crown. It was made around 500 BCE. If you want to go see it, it's currently housed at the State Museum of Egyptian Art in Munich. Silver's been used for hundreds of years to make eating utensils and servingware. Being rather soft, silver for this use was alloyed with copper to make it stronger, thus creating sterling silver. Sterling silver is an alloy containing 92.5% by weight of silver and 7.5% by weight of other metals, usually copper. You can usually identify sterling silverware because it will be stamped with sterling somewhere on its surface. This is the stamp on the back of a silver plate I have here at my house. Silver has been used for thousands of years to make jewelry, usually sterling silver. It's an obvious choice for jewelry. Silver is easy to fashion either by hammering because it's malleable or by casting because it's easily meltable, and it provides a beautiful silvery appearance, even if you do have to polish it once in a while because it tarnishes. Most solder used in plumbing and electronics are now alloys of tin, silver, and copper. Now that we're no longer using lead in our solder anyway. This is low temperature, less than 500 degree Fahrenheit silver solder, used to solder, again, electronics or silver-plated items. This roll contains 5% silver and 95% tin. Higher temperature, up to about 1300 or 1400 degree Fahrenheit melting point silver solder, contains a much higher percentage of silver, from about 56% to 80%. Now here's an interesting use of silver. Photographic emulsion is light sensitive because of silver. Most commonly in silver gelatin photography, It consists of silver halide crystals. That would be silver chloride, silver bromide, silver iodide. And those crystals are dispersed in gelatin, and that gelatin is coated on a plastic acetate strip, which is what we call film. When light hits these crystals, a tiny, tiny speck of each crystal, only a few atoms worth of the crystal, turns into metallic silver. You can't see this, but you then take this strip with its just barely exposed silver halides, place it in a chemical bath called developer, and the entire crystal then turns into black metallic silver. You still can't really see it. The unexposed and undeveloped silver haloid crystals are then washed away with a solution called fixer, leaving a clear strip of plastic with a negative image, black where it was hit with light. This is then printed to another emulsion, this time on paper, making a negative print of a negative image, or a positive print. What you see here is called a contact print. And you can see here, this is Frank Oppenheimer looking through the prisms. Silver has the highest reflectivity of any element. It's where silver really shines, if you'll pardon the pun. Unfortunately, it also tarnishes with time and must be renewed. So most mirrors that have a silver coating are actually aluminum mirrors, which are also highly reflective. Most mirrors are made by evaporating aluminum in a vacuum onto the glass substrate. You can also coat mirrors chemically with silver, though it does require some noxious chemicals and expensive silver nitrate. Here, you can see this process done to the inside of a bottle. And you probably shouldn't do this one at home, but here is this web page which you can go to, which does discuss the process. So if you're interested, check it out. Silver is known to be toxic to bacteria and less toxic to human cells. The mechanisms for this toxicity, not well understood, but that hasn't stopped it from being used. Here are bandages with silver incorporated into the pad. Is this worth the trouble and expense instead of just using an antibiotic cream? I have no idea. I'm not a doctor. Some Samsung home appliances, such as this washer, have a silver nano coating on their inner surfaces for a claimed antibacterial and antifungal effect. Samsung says that the silver nanotechnology sterilizes over 650 types of bacteria for a, quote, maximum of 99.99% disinfection and an added antibacterial effect of up to 30 days after washing, unquote. The South Korean Consumer Protection Board concluded Samsung's silver wash technology was exaggerated in advertisements due to test results which showed that 99.9% removal of germs occurred in similar drum-type washers by LG, Daewoo Electronics, and Whirlpool. It's amazing. Good old soap and water works miracles. These are $64 silver lining shorts. These boxer shorts are made of silver-coated thread. They're meant to protect you from electromagnetic fields, or EMF, if you think you need protecting from EMF with your shorts. This is getting literally into tinfoil hat territory. Back on Earth, though, this is a collection of silver tracheostomy tubes. These are tubes used to keep the airway open from a hole in your throat to your lungs. If you are having trouble breathing, they'll cut a hole in your throat. That's a tracheotomy. And these tubes are then inserted to make sure the airway is clear. These are made of solid silver, perhaps because of silver's antimicrobial qualities. A silver oxide battery uses the chemical silver oxide as the positive electrode and zinc as the negative electrode. This battery has a very high energy to weight ratio, but because it's using silver oxide, it's a bit more expensive than other battery formulations like lithium batteries. I talked about thermal conductivity a little bit earlier. Silver has the best thermal conductivity. So it makes sense to use silver to connect something that's hot, like a computer CPU, to something meant to keep it cool. That thing, by the way, is called a heat sink. This silver paste in the syringe here is just silver powder in a grease carrier. They spread this between the top of a CPU chip and the heat sink. Here you see the CPU and the heat sink. The paste efficiently conducts the heat away from the CPU and into the heat sink, where the heat is removed by moved to the air by the large area of the heat sink fins, which are fan ventilated. This is a sputter coater, and it's used to prepare specimens for electron microscopy. To look at a specimen in an electron microscope, you need to make it electrically conductive. And as we mentioned, silver is the best electrical conductor. This device completely covers a specimen with a variety of metals. You don't have to use silver. You could use palladium or gold or silver. Here you see a spider that's been coated with gold, or an ant also covered with gold. When you put these samples in an electron microscope, you can magnify an object tens of thousands of times, much more than an ordinary optical microscope, revealing truly amazing detail. You're seeing an ant's head here. Silver plays no natural biological role. It's not normally found in the human body at all, except for one possible exception. It's not there naturally. You do find it in dental fillings in your teeth. But that's not a biological role, that's a mechanical engineering role. Dental amalgam is 50% mercury and 22 to 32% silver with a few other metals. This combo of metals is designed to match exactly the thermal expansion of your teeth. Your fillings cannot expand more or less than your teeth without disastrous consequences. So you don't want your teeth cracking when you drink a hot drink or a cold drink. So very important that that filling expands at the same rate as your teeth do. And that leaves us with our parting silver haiku by Mary Soon Lee. Treacherous treasure, avarice tarnishing us, photos claiming souls. Thank you for watching Everything Matters, Tales from the Periodic Table Silver. Our next element in this series will be element number 48, cadmium. This is your host, Ron Hipschman, for Everything Matters, a production of the Exploratorium in San Francisco.